Hi guys, welcome to question 3 of the 2016 electricity paper. In this video, I'm just going to try and finish the rest of this paper. So let's get started. Question 3, electromagnetism. A metal rod AB of a length is free to slide without friction on two parallel metal tracks, blah blah blah. When the switch is closed, the rod AB moves. Okay, question is, in what direction does the rod AB move when the switch is closed? Alright, well, even if you don't know this, it's a 50-50 guess. It's either going to go left or right. It's not going to go up or down, obviously. But we can know for sure which way it goes using the right-hand rule. Alright, so these X's tell us it's going to be, the magnetic field is going to be into the page. So that tells us it's into the page. So you'd be pointing your fingers away from you. We can see that this is the positive side, the longer side's positive, which means the current, if I just, is going to go from dot B to A. So that means the current is going upwards from B to A. So if we point our thumb upwards and our fingers away from us, we'll see the palm of our hand is facing the left. So that means the force is to the left, so the rod will move to the left. So the rod will move to the left. Okay, and we know that from our right hand rule. Okay, if you get it correct, it's an achieved. Okay, next question. Calculate the size of the force experienced by the rod AB. Okay, our force formula is F equals BIL. I don't know why there's all these random marks. I'm just gonna. Okay. So our B. So I'll just write it here. B is our magnetic strength, which is 1.5 times 10 to the negative 3 equals 1.5 times 10 to the 3. Okay, our I, we don't know what that is yet, so we're going to find it. It doesn't tell us anywhere. They give us a voltage and they give us a resistance, so we can find the current. And then our L is just the length, which is 0.16. I've already converted it to meters, so that's good. So 0.16 meters. So we got to find I before we can do anything. So I, well, I'll do it like this to make it more clear. V equals IR. So I equals V over R. That's just rearranged. So I will equal our voltage, which is 12. So 12 over our resistance, which is 20. So I will equal, let's just put that in the calculator. It's going to equal 0.6 amps. So our force is just going to equal 1.5 times 10 to the negative 3 times 0.6 times our length is 0.16. Okay, putting all that into your calculator, you should get an answer of 1.44 times 10 to the negative 4 meters. Sorry, that just took a while. Okay. This is a merit question. For merit, you need to have found the correct force. So that's merit. Achieved is correct current or incorrect current, but somehow you got the correct force. So let's just call that achieved, correct current. Alright, next. The battery is removed and replaced by a conducting wire as shown below. The rod AB is pushed to the left at a constant speed of 3 meters per second. Explain why a voltage is induced. Alright, so within this I'm just going to draw it. Within this rod, there are electrons. You can't see them, but just imagine there are, and they're just going to be in there. So that's got all these little electrons within it. So basically, they're going to all experience a force. So these electrons are going to experience a force, right, which is by the magnetic field. Experience a force, right? Which basically is going to make them all move around, and that's what causes an induced voltage. So that's literally all we have to talk about. It's not that much detail. So we can just write something like the electrons in the conducting rod. Let me just delete this. Experience a force provided by the magnetic field and they move, which creates an induced voltage. Okay, that's all we need. So this is a merit question. You need to have a correct explanation for merit. So you basically needed to have talked about the conducting rod having an electrons and that they experience a force which causes the induced voltage. So I'll just write merit is like full answer. Okay, achieved is partial explanation. So maybe just talking about the electrons in the conducting rod experience. So that would be, just up to there would be an achieved. Okay, final question. Calculate the size, so two parts, size and direction of the induced current, conventional current. Okay, that's actually something important. Flowing through the metal rod when it is moved to the left with a constant speed of 3 meters per second. Alright, so to get the current, right, we need I equals V over R. Now, we have the resistance, but we don't actually have the voltage. It's not this anymore. It's not going to be this 12 because here, right, it says the battery has been removed and it's been replaced by conducting wire. So we don't know the voltage of that conducting wire. So we need to find the voltage, but luckily we have an equation. It will be V equals BVL. And you know it's going to be BVL because we've got this speed here. Okay? I should probably write that as a capital. Alright, so V equals our magnetic field strength, which is still going to be that 1.5. That doesn't change. 10 to 3. Speed is 3. Right. Times 3. Times the length, which is still that 0.16. 0.16. I'll just make sure that was the correct length. Yeah, 0.16. Okay. So that's gonna equal 7.2 times 10 to the negative 4 volts. Okay, now we've got the voltage. Now we can find the current. So this is I equals 7.2 times 10 to the negative 4 divided by 20 because the resistance stays the same. So our current, if we put that into our calculator, it's going to equal 3.6 times 10 to the negative 5 amps. Alright, we're not done yet. We've done one part of the question. We still need to state the direction of the current, okay? Current. So, anytime they ask you for direction, you always got to use the right hand rule. You won't really use anything else. So, I'll just do a line direction. So using RH rule. So if we go back up here, so the magnetic field is still into the page, right? But now the force, our rod or whatever, is going to be moving towards the left. So if we point our thumb towards the left and our fingers into the page, so away from us, we will see the palm of our hand is going to be facing downwards. So that means the direction is going to be from A to B. So we can write conventional current, because we want to answer the question. Conventional current goes downwards from A to B. Okay, and that's it. We're done. So it was A to B. Okay, so this is an excellence question. To get excellence, you need to have done everything. Okay, so you needed to have found the current, the correct current, and you needed to have stated it goes downwards from A to B. So excellence is full correct answers. For merit, you just needed to have two of, so you either had the correct direction of the current, or the correct working for the voltage, or correct working for the current. So let's just say you got up to here. I'd say that's a merit. And if for achieved, you just need any one. So let's just say here is achieved. Okay. And that is it. We have finished the 2016 paper. I'll probably upload more exams soon. And yeah, any questions, leave a comment. Cheers.